Hi everyone! We'll be exploring Activity 23 from Unit 4 in Springboard for this video. Activity 23.1 is compound interest. We will create an exponential function to model compound interest. Compound interest is a math term meaning interest or money paid by a bank to an account holder that is earned on both initial account funds, which is the principal, and previously earned interest. Let's look at the formula for compound interest. A equals P times 1 plus R divided by N to the T times N power. Let's go over each element of this formula. So A is going to be the amount, the total amount. P is going to be the initial value, or that's the amount that you have invested. R is the interest rate that the bank is going to pay. That's usually a percentage. N is the amount of times the investment is compounded per year. For example, they can compound it annually, which is one time a year, or quarterly, or monthly. And T is the time. Madison received $10,000 in gift money when she graduated from college. She deposits the money into an account that pays 5% compound interest annually. We are going to add what will the total amount of interest earned be after 8 years. Okay, let's look at what we know and plug it into our compound interest formula. Madison's initial value was $10,000. That's what she first put into the bank. The interest rate the bank is paying is going to be 5%. They are going to compound annually, which is one time a year. And the total amount of time that we're looking at is 8 years to see how much she's earned in that amount of time. Now that we found the values for the formula, let's plug them in. Amount equals the initial value of $10,000 times 1 plus the interest rate, which is 5%. In order to make it a decimal, you have to move the decimal 2 places to the left. So 0.05 divided by the amount of times it's going to be compounded in the year, which is 1. And then so that's 1 times, we're looking at 8 years. I rewrote the formula so that we could look at it a little better here. So the amount equals 10,000 times 1 plus 0.05 divided by 1 is going to give you 0.05. Anything divided by 1 is itself. So, and then 8 times 1 is going to be 8. So we need to remember PEMDAS at this point. The first operation, because it's going to be tempting to do 10,000 first times 1 plus 0.05, but you have to remember that the P stands for parentheses, so we need to do what's in there first. So the amount equals 10,000 times 1 plus 0.05 is 1.05 to the 8th power. And looking at PEMDAS again, E stands for exponent, so we need to calculate the exponent next. I'm going to use my calculator for that. 1.05, and then you want to hit the X to the Y key, and then 8. And that will calculate your exponent. You're going to take this amount and then multiply it, that's what's next, by 10,000. And that's going to give us our total amount that she earned off of 10% interest after 8 years. She earned $14,774.55. We're going to be rounding to the nearest whole number, so we'll put $14,774. That is the total amount. Now, if you don't have a calculator, you can use Desmos.com and scroll all the way to the bottom. You'll find Scientific Calculator. Press that, and you will see the calculator pop up. And here you can enter to solve 1.05. They have the exponent button also to the 8, and it gives you your answer over to the right. Then you'll multiply that by pushing the multiplication key by 10,000. And it shows you your answer right here on the right. You just need to round it. So on number 2, it says Madison wants to record the amount of money she will have in her account at the end of each year. Complete the table, round amounts to the nearest cent. If you look at year 0 where she first started, she started with $10,000. After the first year, second, third, fourth year, you can see when they get to the 8th year, that's where we calculated, and we got the same amount there. So it's just showing you after each year you can plug that in for the time in the formula, and that's what you will get. On number 5, you are going to be, instead of calculating the amount of money in the account after each year, write an expression for each amount of money using 10,000 and repeated multiplication of the constant factor. Then rewrite each expression using exponents. So this is what that looks like. You're going to take 1.05, say on number 3, to the third, and just multiply it 3 times by 10,000. Most saving institutions offer compounding intervals other than annual compounding. For example, a bank that offers quarterly compounding computes interest on an account every quarter, that is, at the end of every 3 months. Instead of computing the interest once each year, interest is computed 4 times each year. If a bank advertises that it is offering 8% interest compounded quarterly, 8% is not the actual growth factor. Instead, the bank will use 8%, 0.08, divided by 4, and that'll give you 2% to determine the quarterly growth factor. Number 20 says, what is the quarterly interest rate for an account with an annual interest rate of 5% compounded quarterly? So what you do is you take 5%, 0.05, and divide it by 4, and that'll give you 1.25%. Interest can be compounded semi-annually every 6 months, quarterly every 3 months, monthly, and daily. For the compounding periods below that are given, we're going to calculate the same thing we've been doing for this lesson. Madison has invested $10,000 at a rate of 5% annual compound interest after, we're going to do after 8 years. So yearly, if you dot out the months at the top, January, February, March, April, May, June, July, August, September, October, November, and December, that gives us 12 months. So after 12 months, that would be yearly. So one time is yearly. Now if you're looking at quarterly, you're going to divide it after 3 months. January, February, March, April, May, June, July, August, September, October, November, I must have missed a month. But anyway, you get what I mean. After each 3 months, they're going to do compounding on that. So that's 4 times in a year if they're doing quarterly. Then monthly, they'll compound after every month. And so that's once a month for 12 months, so you get 12 times. And then daily, of course, let's see if we're just going to say that there's 365 days in a year, so they're going to do it 365 times. So compounded yearly is once, and we did that already in the lesson. So we're now going to compound quarterly, which is 4 times. You're now going to place the 4 in place of the N for amount of times that the bank is going to do the compound interest. So we're going to work out the problem. A equals 10,000 times, now we're going to work out 0.05 divided by 4, get 0.0125, and that plus 1 will give you 1.0125 times 8 times 4 is 32. Okay, now remember to do your exponent next. So 1.0125 to the 32nd power is going to give you 1.488. You're going to take that number and multiply it by 10,000. So A equals $14,881.30, but after we round that to the whole number, we'll take off those cents. Now we're going to compound monthly, which is after every month, and that's 12 times. So make sure you replace the N with 12 this time. And we're going to do 0.05 divided by 12 to give us 0.0042, because we rounded that. And then that plus 1 gives you 1.0042. And 8 times 12 gives you 96. Remember, don't multiply 10,000 first. We have to follow the orders of operations, and that's going to be 1.0042 with your exponent of 96. Now you're going to take 10,000 times 1.49. How about we just round that to 1.5? Okay, now let's multiply 10,000 times 1.5. We get $14,953.43. And if it's compounded daily, that means every day, so 365 times. So you're going to replace the N with 365. That's the number of times it's compounded. It's still at 5% interest, so you take the 0.05, divide that by 365, and then add that to 1, and you're going to get 1.00014. Then multiply 8 times 365 to get 2,920. Let's do the exponent first. So 1.00014. And you get 1.8 equals 10,000 times 1.505. Multiply that by 10,000, and the total amount is $15,049.68, which we'll round to the whole number and put the total amount as $15,050. Okay, at the top of page 346 on problem number 22, let's fill in the functions that represent the balance in Madison's account, and then we'll put the total. So A was yearly, so it was compounded once, and our total amount was $14,800. B, the compounded quarterly, is 4 times a year, and the total amount is $14,880. C is monthly, which is compounded 12 times in the year, and the total amount is $14,953. And D is daily, which is compounded every day, so that's 365 times in the year. The total amount is $15,050. If you look, you will see, I think that's number 23. What is the effect of the compounding period on the amount of money in the account after we did 8 years, as the number of times the interest is compounded each year increases? So as the amount you compound increases, the amount of earned interest increases as well. If you notice, it went up a little each time. So I want you to try 22 and 23 using a 20-year time period and watch how much more interest Madison will make.